Hello everyone, my name is Hubert and welcome to Teach Me channel. Today we'll be looking at GCSE Maths Proportion Algebra. Previously we made some videos on proportions, on some basics of how they work, and we made a video on some less conventional proportions. Now this is the ultimate video on proportions we're gonna be doing, and we're gonna tackle the big one. We are going to tackle how to handle questions that involve algebra, with proportions, how to solve these algebraic questions. So it may sound scary, but don't worry, we'll go through it step by step. If you haven't watched the previous two videos on proportions, make sure you watch them because they have a ton of useful information that I'll be using here. So if you haven't watched those two previous videos on proportions, make sure you watch them. I will include the links below in the description so you can access them nice and easy. So, without further ado, let's get started. Now, the way to teach you that in the most straightforward way is to just tackle some questions. First question, we are going to do some basic question to sort of familiarize ourselves with the algebra, I suppose, the algebra involved in proportions. And then we're gonna hit a harder question, much harder question, and we are going to solve that as well. Don't worry, we'll go step by step, and I will make it as simple as I possibly can for you guys. So, what is the question? An object is moving with a velocity that changes proportionally with time. After 7 seconds, its velocity is 206 meters per second. How fast will it be after 24 seconds? So we have an object that moves with a certain speed, and we know that at 7 seconds it's so fast is 206 meters per second. And we just need to find out what is gonna be the speed, the velocity, more precisely, of the object after 24 seconds. Now, we also know that this change is proportional. So here, straight away, we know that we are talking about direct proportions. So I drew up a graph here, velocity in y-axis, time in x-axis. So because it's the direct proportion, we have a line going like this. And at 7 seconds we are going at this velocity, and at 24 seconds we are going at this velocity. So it's all dependent on that straight line. Now, if you knew the values here, you could look it up on a graph and give an answer that way. But obviously we don't know the values because the point is to calculate this using algebra. So now, before we tackle any algebra, the very first thing we need to do is simply write down the proportionality that we're dealing with. So we are dealing with velocity being proportional to time, directly proportional. So we are simply going to put down v is proportional to t. That's it. So now the second thing that you will always do when it comes to proportion algebra is to change that proportionality into an equation, a proper equation. And we will do that by adding a constant k, as previously discussed. So the equation for that will be v is equal to k multiplied by t. And that's the proper equation that we are going to use to solve this. Now, we are given 7 seconds and we are given the velocity at this time. So knowing those two pieces of crucial information, we can work out the constant. We can work out the rate at which the velocity changes with the time. So in order to do that, we simply have to rearrange this equation to make k the subject of this formula, to make it so that k equals blah 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 blah. Okay. So we will do that by dividing t on both sides. So v divided by t is equal to k. I'm going to flip this the other way around, so k is equal to v divided by t, just to make it a bit more clear. Okay, so that is how we are going to work out the constant. So now we are just going to plug in the values here. Nice and simple. So k is equal, in fact, to 206 divided by, because that's in meters per second, so we're dividing it by 7 seconds. So 206 divided by 7. And that will give us the constant. So the value for that is k is equal to, it was equal to 29.43 if you plug that into calculator. So k is equal to 29.43. Now we know the constant, so now we need to go back to the original equation and plug that constant in. That's very important. I will go through this in a second. So all we are doing is plugging that value for the k in. So v is equal to 29.43 t. And now, why is that so important? I am going to underline this. Actually, I'm going to put it in a box because this is absolutely crucial. Now, this is important because a lot of questions will ask you to give a value for one part. So in this case, to give a value for v in terms of t. And what does that mean? That means that we need to bring it to this form. So v is equal to however many t's. So that's what it means by in terms of t. It basically means how many t's 1v is equal to. Simple as that. So that is very, very, very crucial piece of information. Now, lots of questions will be asking you that, so you must bring it down to this form. By essentially, all you have to do to bring it down to this form is just find the constant k by rearranging the equation. Okay, so now we got the constant k, we got the v, we got the t, and we got the constant k. Now, we are going to apply this to figure out the answer of how fast will the object be after 24 seconds. So t, the time is 24. So basically, we are just going to plug numbers into this equation. Simple as that. So v, because we don't know v, that's what we want to find out, is equal to 29.43 times 24 seconds. I'm going to put that down in red. So that's times 24. And that will give us the answer. That will give us the velocity after 24 seconds. So if we multiply these two, if you plug that into a calculator, it's going to give you answer looking somewhat like this. V is equal to 706.32 meters per second. Now, that's our answer. I'm going to underline this. That's our answer. And so this is how we arrived at it. First, we figured out the proportionality. We simply wrote down what the proportionality, what the relationship is. And that's how you got to start. That's every time you're going to start like that. Then you just change that into an equation by multiplying one side by k. And that will happen in every case of proportionality, as I explained in previous videos. And then we need to find the k. We need to find the actual constant. What on the earth it actually is. So we simply rearrange the equation, divide v by t, and we arrive at the value of k. Now, knowing the value of k, we actually arrive at the very important form where we have v in terms of t, and then we substituted the value of t, and we multiplied all of that out, and boom, we got the answer. So that hopefully introduces you to the basics of proportional algebra. But what if we were to ramp this up? What if we just gonna make the question more difficult? Well, you will find that those same principles will work in the more difficult question. So let's do this. So here we have the second question. Now this one's going to be a bit more difficult, but don't worry, we will go through it together and I will explain it step by step. Now the key thing here is that as it may be more difficult, we are still following the same core principles from the first one. You will see the exact same core principles and they will take you from the beginning to the end of most questions, you know, even the very difficult ones. So, here we have a question. P is inversely proportional to the cube of E. Now, when P is equal to 0.5, E is equal to 2. Find an equation for P in terms of E and find the value for E when P is equal to 3. So now this is a two-parter. So it gives us the proportionality relationship between P and E. That basically means that P is inversely proportional to E cubed. That's all it means. And it gives us the two points, the two values, P value and corresponding E value. And using that, we need to find an equation for P in terms of E. And then now the second important part is to find out the value for E when we have the value for P, which is equal to 3, and we don't know what the value for E is. Okay, so now again we are sticking to the core principles now. So the first principle was to write down the proportionality, simple as that. Now because P is inversely proportional to the cube of E, we are going to write it down like so. P followed by proportionality sign as always, and then it tells us that P is inversely proportional. I'm just telling you how to sort of read these questions if you ever get confused by them. So P is inversely proportional, so we are doing 1 over to the cube of E. So we are doing 1 over E, but because it is to the cube, we are cubing that E. So that's the proportionality. Now, the second principle is, like before, just to form a proper equation. So P is equal to K, because we are adding just a constant, 1 over E cubed. Now, we are just adding a constant. As always, we are just multiplying this by a constant. Now, as I explained in the previous video, the shortcut here, where because we have a numerator number 1, so that K will always be multiplied by 1, we might as well do it like so. P is equal to K divided by E cubed. That's all we have to do. So now we have this sort of equation, but now what we need to do is we have a value for P, we have a corresponding value for E. However, we don't have value for K. Now, that's very crucial. Again, we have to find as it even asks here, we need to find the equation for P in terms of E. How many E's basically it takes for a P, basically. Okay. So, we are going to find K simply by rearranging this. So, we are going to multiply both sides of the equation by E cubed. So, on this side, we have P, E cubed, and on this side we have simply K. Now I'm just going to flip this around for clarity. K is equal to PE cubed. Now all we have to do is plug in those values. So K is equal to how many P's? 0.5. 0.5 times 2 cubed. 2 cubed. So 2 cubed gives us 8. So 0.5 times 8 is 4. So K is simply equal to number 4. Simple as that. So now we can we are going back, same as before, same principle. We are going back to the original equation, and we are making an equation for P in terms of E. So using this one as a template, we will come up with such an equation. P is equal to 4 divided by E cubed. Simple as that. We only just inserted that constant value, and that is the equation for P in terms of E. Now, so what do we do with that? Well, now the final thing that's left for us to do is to find the value for E when P is equal to 3. So now let's write this equation down with P equaling to 3. So 3 is equal to 4 divided by E cubed. Now, as you can see, they threw us another hurdle here, because E is on this side. Now we need to rearrange this in such a way that E will be here on one side and it will be isolated, as always. So, what do we do in such a situation? Well, we just have to rearrange this. So, we can do it in a two-step way. First, we will multiply both sides by E cubed. So, 3E cubed is equal to 4. And now we are just going to divide both sides by 3. So, E cubed is 4 divided by 3. And now the final thing is we need to get rid of that cube. So we are just going to put a cubic root on both sides. So if we put a cubic root on here, we simply get E. And if we put a cubic root on here, we will get a cubic root of 4 divided by 3. And that is our answer, guys. Now we are just going to obviously calculate that. And if you put that in a calculator, you would get something like this. E is equal to 0.53. Guys, that is our answer. So you can see how we followed. Now, this question was a little bit more complex. There were a few hurdles in a way, but we still followed the core principles. We came up with the proportionality. We came up with the equation, and then we found the constant K, and then we used that constant K to find an equation for P in terms of E. And then it's just, going downhill. We just have to rearrange some stuff and just come up with plug in the values and come up with what they wanted us to come up with. So, this is it for today, guys. I hope this video helped you immensely. If it did, give me a big thumbs up. If you have any questions whatsoever, I do realize this topic is hard. If you have any questions whatsoever, shoot a question in comments. I am more than happy to help you out, guys. Thank you very much for watching. I really appreciate it, guys, when you watch my videos. If you want to stay up to date with daily math, science, and some biomedical science videos, hit that subscribe button below. Don't be shy. Thank you again for watching, and see you next time.